Hi, in this video, I'm going to teach you how to find the relative extremum point. Okay, as you know that relative extremum point is actually the relative maximum point or relative minimum point. So, and this is the function given. So then they require to find the relative extremum point, means find all the critical points. All right. For these cases here, we refer to relative extremum point. We finding the dy dx. Okay, f prime x. We have to find f prime x and determine whether the relative maximum, the point is a relative maximum or minimum point by using the second derivative test. Right, which is stated that you have to use the second derivative test. Alright, so or anything, so if you want to find a relative extremum point, so you have to f prime, you have to equal this to 0, differentiate and equals to 0. So for this case here, your fx is x squared e to the power of negative x, right? So you know that for this you have to apply the product rule, right? Product rule. So you have to differentiate. So the formula would be u v prime plus v u prime. So so x power of 2, v prime, differentiate e power of negative x. It will be e power of negative x, differentiate the power, you have negative plus with e power of negative x, okay, v u prime, differentiate x squared, you will have 2x. So you are getting the, you can factorize the common factor here. So e power of negative x is a common factor. Then you will have negative x to the power of 2, negative x to the power of 2, right? Negative x to the power of 2 plus with 2x. So this will be your f prime x, right? So see that I factorize, I'm getting this. So then for this case, so how to find the relative extremum? So we have to equate it to 0, right? So we have to equate negative e power negative x, negative x squared plus 2x equals to 0, right? This function, exponential function, multiplied with this quadratic function equals to 0. As you see that this exponential function is always positive, right? It's always positive. So it will not be 0, okay? It will not be 0. For any value of x, it will not be 0. But it can approach to 0, but will not be 0. So this one multiply this one, you are getting 0 is because of this, right? The quadratic here. So it means that, therefore, you know that the negative x squared plus 2x is the one that causing the equation to be 0. So factorize, you will have x, right? You can take out the negative x, then you have x minus 2. You have negative x squared, positive 2x. So you're getting two roots, 0 and x equals to 2. Actually, if you consider f prime x to be 0, and this will be your stationary point, right? Or we said this is your relative extremum point. It can be maximum or minimum, right? So we have 0, we have x equals to 2. So, okay, for now I have to find the value, the coordinates, okay, the coordinates of these 2 points first. Right, by substitute the value of x equals to 0 to find the value of y, right? To this function here, y. So y will be 0 squared e to the power of negative 0. So you are getting 0, right? 0 multiply exponent, you're getting 0. So it means that this is one of the relative extremum point. But maximum or minimum, we don't know. We don't know whether this is maximum or minimum because we don't know. So then we have to do some tests. So x equals to 2. So when x equals to 2, what happened? When x equals to 2, so y will be 2 to the power of 2, e to the power of negative 2, right? So x is 2, so 2 squared. So you are getting 4 over e to the power of 2, right? So then you're getting another coordinate, which is 2, 4 over e to the power of 2. So for sure now, you don't know whether this is maximum or minimum. So that's why the question is ask you to, okay, you have already find the relative extremum. You already find the relative extremum point. In this case, it's a stationary point, right? Because the dy dx equals to 0. So, and This will be your relative extremum point. But you don't know whether they are maximum or minimum point. That's why they said by using the second derivative test. Alright, so let's see how I'm going to use second derivative test. Alright, okay. So we are using for second derivative test. So I have to find the second derivative of the function fx, right? So then I have to find, and as you see that this will be also a uv function. Okay, uv is a product rule between exponent and this. So I'm going to apply product rule one more time. So where I copy back the uv prime plus vu prime. So u, negative x, okay. Then differentiate v prime. V prime, so you have negative 2x plus with 2, right? Negative 2x plus with 2 plus with v. Copy back the v, negative x squared plus 2x, and differentiate exponent. You will have negative e negative x, right? Again, the same thing happened here. You're going to factorize. So e power of negative x, you can take out the e power of negative x. So, and you will have inside to be negative x to the power of 2. You have taken out these two, right? So you will still have negative x power of 2 as the highest degree, and plus 2x, right? Plus 2x minus 2x. Plus 2x minus 2x, you have 0, right? Plus 2x minus you have 0, and plus with 2. So this is your second derivative, right? This is your second derivative. So the second derivative here is, now I want to using this to verify, to determine whether this is a maximum or minimum point, right? So, okay. So now I have 2 points. I have x0 and x is 2, right? So I have when x is 0. When x is 0, then what is your second, the test? Okay, you will substitute f0. Use 0. So if you substitute 0, what happened to this? So you have e to the power of 0, right? E to the power of 0, which is 1, and negative 0, 0. Then you have 2, right? And you have 2 here. So you have 2. So then this case happened to be, this is 1 times 2, which is 2, which is a positive number. Based on the knowledge for second derivative test, so if the second derivative test give you a positive number, so means that, therefore, the 0, 0, the origin is a local minimum point, or is a relative minimum point, right? It's a relative minimum point. All right. So how about the second one, right? The second point. So you're just using the value of x2 to identify, substitute into the second derivative. Okay, substitute. So then you have to state when x is 2, right? So what happened to your second derivative test? So you substitute inside here, you have e to the power of negative 2, then you have negative 2 to the power of 2 plus with 2. So you are getting like e power of negative 2, and this is negative 4 plus 2, you have negative. So you're getting a negative number because exponent always positive. So negative times with this one is negative. So based on the test, the second derivative, the sign for x equals to, when x equals to at this point, so the value of f second derivative will be less than 0. So this one shows that 2, 4 over e to the power of 2 is a relative maximum point. Negative will be relative maximum point. Alright, as easy as that. So means that you have found your relative extremum point, then later you identify whether they are maximum or minimum by using second derivative test for this case. Okay, I'm going to show you. So you have graphing, so you have Desmos apps. Okay, this app is very powerful apps, so you can use to check your answer or your graph. So okay, let's see. Okay, and I'm not going to teach you how to sketching this graph, as if you're sketching this graph, you need to know the asymptote. The asymptote for this function. So which you have already learned in limits and continuity, where you learn about how to finding the horizontal asymptote, the vertical asymptotes. All right, if you try to consider that, then you will see. So okay, now I just want to talk about the point, right? So let's key in this function into this apps here, the Desmos. All right. So I show you the apps. So this is the apps, the Desmos. So okay, then you key in the function x square, right? X square. Okay, x square, then exponent, you key in the function. Can you see there is a function here? Okay, choose the function. So the function here is exponent, exp, exponent, oh sorry. So you're choosing the function, and you see there is a exp here, right? Exp, okay, exp, then bracket, bracket. So exponent to the power of negative x, then you're putting negative x. All right, okay, that's all. So you have x squared exponent power of negative x. Okay, then you observe the graph, right? You will see the graph. I try to zoom. Okay, where's the graph? So right, okay, let's look at this. You have 0, right? Can you see, if you see carefully, if you zoom carefully, during the origin, can you see there is a relative minimum point here, right? As you see that 0, 0 is a relative minimum point. So if you see, if you zoom carefully about this function, so you can see that it's a minimum point, right? If the graph will be going down here stationary and going up again. So if you're going again, then you will see another stationary point. All right, there's another stationary point where the graph increase, suddenly decrease, right? Can you see that? See that the graph curving, right? It's curving. So moving up, then going down, means that the point 2 here, can you see the point 2 here? The point 2 4 over e squared. 2. The 2 and the value of y is 4 over e squared is actually a stationary point. So as you zoom, you see that the graph going up, and later after this point, the graph going down again. Can you see? The graph is going down, right? So this is a relative maximum point. All right. So okay, this is all you have to understand. You have to know, which is using second derivative test to identify the relative maximum and minimum point. Okay. See you in the next video for the next example.